I'd just like to open with an introductory question to the panel, and maybe each of you can give your opinion on how kind of more detailed geological mapping or data or information being produced, how this can inform or contribute to better informed decision making across sectors like land use planning or resource management or environmental protection, for example.
Okay. I would like to start with a very small piece of geology to bring it to your imagination, because it derives from my own work as mapping geologist in the Austrian Molar zone in front of the Alpine origin, especially along the Danube, but also far from it you find wind-blown loess deposits in sometimes amazing thickness, and they're very important for agriculture, very good soils. So that's the topic of land use management and planning. And it's really amazing in which strange position you find those wind-blown sediments, because they're not underthrown simply like in water environments, but they are blown up the hill as well, and you have to understand those wind systems. And why is this relevant for land use planning, for example? Because of contamination with the remnants of pesticides from agricultural land use, yeah? And to have good land use management plans, you need a very, very detailed geological map. So not at the scale of 1 to 500,000 or 1 to 100,000, but at least 1 to 50 or 1 to 25,000. Yeah? So of course, my expectable answer is yes. We urgently need this information, and what I frequently, or relatively frequently, see is that the right people come and put the right questions. Do you have geological information, maps or models from that region? And the data are missing. So it's not only a problem of harmonization and communication and open access, but also a lack of this data. And this is why, if you listen to Julie, you find such keywords like updating, reinvesting, strengthening of existing or new national mapping programs.
Okay, I will say a few words on the, let's say, from the digital transition view. I agree with you that we need new mapping programs, that we need new, fresh data. But it would be good also that we are using the same standards, that we are using the same vocabularies, that the data, I mean, through that it will be interoperable, that we can share, that the different stakeholders, it doesn't matter which one, but the different stakeholders can get our data and that can be used. The important thing for me is also that we have the same definitions, that we understand what we were, let's say, what we have on the map, is that the same understanding through in different countries, through cross-border. So that is, for me, important also, of course. The new data know that definitely needed.
A short remark from my side. I think the important concept here is scale. So if you ask me, do we need more detailed information on a European level? Probably not. We can have very interesting discussions with Christine, who created that map Julie showed, to understand how we can transform very detailed national or local geological information into a pan-European or global map. That still makes sense. So you should make products or maps that are applicable to the scale of the one who asks you some questions. So if you're talking about European policymakers, the scale in the, will be different than when you're talking to a local policymaker, let's say. And the good thing is that geological surveys can cover that entire range. So scale is important, and joining our efforts as a geological community in that is important.
Okay, in that case, one topic came to mind. Maybe this is more for Stephan. You had an image in your presentation with the help of AI, and you know, the last few years especially, this is something that's been discussed more and more in the community. How can we make use of AI and machine learning and all of these things? And obviously this is something we need to look at in a lot more detail. So what kind of potential do you see for AI and machine learning in enhancing our geological research efforts, and in particular around digitization and enhanced mapping and quality of data?
I think that AI is a very powerful tool, but when you give a powerful tool to a fool like me, the result is still unusable. So AI can help us speed up things because we have to interpret more and more data. The amount of data that will flow to us from monitoring, streaming data will grow tremendously. And within that streaming data, there's a lot of data, but it's not all meaningful. So we can use AI to really extract meaningful information from all that stream data that comes towards our organizations. But in the end, it will always need the expert eye, so not the eye, but the eye, to check whether or not the outcome makes any sense. And there the picture again was very useful. A simple question sent to a chatbot, and he creates this picture and it looks very good, but it doesn't make any sense. But it was very quickly though. It was 20 seconds. And ask Christina how long it took to create the one geology map. So it will help us speed up, but we need to check.
Yes.
My experience with the AI was not so good. We didn't understand each other. I asked the questions and he didn't know how to answer. And so I am waiting for the next generation of AI. The fact is also that you need the data you trust. You need otherwise, I mean, I like the expression garbage in, garbage out. You cannot expect a miracle. So that's why we really need to concentrate to high quality data, the data we can trust.
I remember the nice example of a colleague from UK who experimented with geochemical stream sediment data and integrated them via artificial intelligence with elevation data from laser scanning, airborne laser scanning. And he managed to reproduce the well-known oldest geological map of the world from England with the relatively simple geology there. And that's a really great example and application. And maybe something similar can also be done in more complicated areas. For example, in a fallen thrust belt like the Austrian Alps, but only with regard to which rocks might appear at which place but not yet, for example, to resolve the tectonic structure of this complicated part. Maybe we'll see this ability of artificial intelligence. I still cannot imagine that something like that will be possible.
I'm Marko Komac. I'm representing IUGS here, but also other hats on or off, however you want it. Anyhow, in IUGS, just to show a little bit of background, we have a huge discussion on the currently being developed GeoGPT, which is pain in the neck, I would say, currently, because we are fighting over it. Anyhow, you have in your document this nice pyramid from the data to information to knowledge at the top. So I would suggest, to avoid any misinterpretation, to put AI between data and information, or information and knowledge, and to show where it actually belongs, so nobody that's not acquainted to it would think, okay, we've solved now the issue with the data and now we can just use AI and get the perfect 3D geo models out of it. Just to make sure that you hold those expectations down to reality. Thanks.
Thank you. Just a quick comment about AI. From our perspective at BRGM, we are now developing a lot of AI applications. They are still on R&D stage, not on operational services, but it's obvious that within 2 years there will be operational services using AI applications. The quick comment to Stephan for the writing for the next upcoming version, the next version of the 3 but we didn't mention the AI Act in the document, which has been released this year. And considering the kind of data geological surveys publish and release on, it's obvious that we may, some of these data will include or may include some additional data produced by AI that may be classified according to moderate risk or the upper category, elevated risk, according to the AI Act. So we have to be very careful because we are already part of that classification. So we should highlight that in our document.
Gilles? Thank you very much. I will move to another questions and forget about the AI and come to the real intelligence, which is not mine. I have a questions about Europe. So you talk about this digital data and acquisition in geology, which is very important. In my view, I'm a marine geologist, and I will have other questions for this SRIA, because I think there is a lack of marine vision in the SRIA, and I think it's important because Europe has the first EEZ in the world. But my questions to you is, are you aware of the digital twin of Earth, which is financed by the DigiConnect? And I think the data which should be provided by the Geological Service of Europe should be used by the digital twin of Earth. And I don't know, I didn't see any comment about that, and wonder if you had any connection with that, and if the data which are accessible should be accessible to use by the digital twin owners. Thank you.
Thank you very much. So, where would you like to start? AI?
Let's start with the digital twin. I know from the experience in the Netherlands, they talked about this nationwide digital twin that we could use to solve all the questions that we have. There I said, well, I don't believe in that. So I try to explain that what I do believe is that if we can create this family of applied digital twins tailored at a specific need, then we can get somewhere. And that same holds for when we try to twin the Earth, which is even a bigger thing, let's say, to capture. So what would we need to put in there then? and for what purpose. So digital twinning as a tool is strong, but again here, deciding which process or which thing that you need to twin digitally to get the right answers to your own questions and workflows, that's the challenge. And once you agree on that, then you can start building something digitally to support that. On the AI, definitely AI is happening. It's happening already also in our survey in processing large volumes of paper data that still comes to us because a lot of operators are leaving the country. And we have to deal with that. We simply don't have the capacity to do that manually or the way we used to in the past. So we need to use AI and ML pipelines to actually process a huge amount of data. And at the end, when we disseminate that data, they are all up there at the same level as the other data sets that we created on a traditional manner, let's say. So we need to think on how we can explain that to the end users, and we need to make sure that we can categorize the quality, if it's better or worse or the same, to explain to the end users whether or not they can use it and trust it.
Digital twins, or digital twin, if we would ask people here in the audience, everyone has their own definition what that is. So for me, this is something what I cannot touch, or how it's really everyone thinks different. We have EGDI, European Data Infrastructure, where all the information, a lot of information there is accessible, it's open access, so it's not a problem to connect to every digital twin which will exist sometimes.
Very short comment. As long as we not even have more or less detailed 3D model, a simple 3D model from the geology of Europe, which is still far away from a digital twin, I'm not really, I think it doesn't make sense to write something like a digital twin in our strategic documents. First of all, let's produce a 3D model.